Hello YouTube, Rugved here from Coding Geeks. Today we will be learning about a sorting algorithm called Radix sort. So let's just get right into it. Radix sort, also known as bucket sort, is one of the fastest sorting algorithms to exist with a time complexity of O to N, which is faster than quicksort. Radix sort uses the concept of sorting names in a dictionary in alphabetical order. For example, if I have two words, anchor and apple, so anchor will come first before apple because N is before in the alphabet than P. And in the same way, ball will come before banana because L is lesser than N if you compare in the alphabet. In the same way, Radix sort works on digits. So, for example, if I have 122 and 123, since 2 is less than 3, 122 will come before 123. In the same way, 212 is lesser than 230 because if we go from the left to right, 1 is lesser than 3, which causes it to come first. And when Radix sort is used on integers, sorting is done on each of the digits in the number. The sorting procedure proceeds by sorting the least significant to the most significant digit. While sorting the numbers, we have 10 buckets, each for one digit, 0, 1, 2, 2, all the way to 9. And the number of passes will depend on the length of the number having the maximum number of digits. So in this case, all numbers have a length of 3 digits. So the numbers are first sorted according to the first digit in the units place. That is, 10 arrays are used to arrange the numbers, where the first array stores the numbers ending with 0, the second array stores the numbers ending with 1, and so on. For example, 911 ends with 1, hence it is stored in the first bucket, and then 345 ends with 5 and it is stored in the fifth bucket. Now, if you observe, 345 comes first in the input array, hence it is stored way before 555, right? And now, once we're done with this, all we do is go from left to right and top to bottom, and we keep collecting all these values. So 911 will be collected first, then 472, then 123, 654, and so on and so forth. So we will have something that looks like this. And now we put this back in the buckets, but instead of seeing the units place, we see the tens place. So 808 will come first because it has 0 in its middle place, which is the tens place, and hence it will be in the 0th bucket. 911 will again be in the first bucket. 472 will be in the 7th, and so on and so forth. And the same rule applies. First come, first service. So 123 appears before 924 in the list. Hence, 123 will be placed in the second bucket before 924. And we collect this again and repeat the same thing for the hundreds place. And if you do this and observe, if we recollect this, we will have a completely sorted array here, right? And that is about it. We get a sorted result, and that is the concept of Radix sort. It is a very simple algorithm, but it is super fast. Okay, so let's get to the coding part of this algorithm. Now, I have written some input-output code with respect to our example here in the diagram. Basically, what this code does is takes the input array, calls the Radix sort function, which we are going to create, and then just prints it. So let's create the Radix sort function. Now, I will declare this function as void. By the way, this language is C++, but since the logic remains the same, you can follow along in any language of your choice. So firstly, I'll declare this as void because I will be sorting the array in place. I won't be creating a new one. I'll be just editing this in my function. And vector. Vector is a dynamic array in C++, which is very useful in many cases. So first we start off by finding the max element of our array. So as to determine its number of digits. So I will use a inbuilt C++ function called max element, which I will pass the start of my array, which is input array dot begin, input array, the end of the array, input array dot end. So basically what this inbuilt function does is finds the maximum element in my entire array so that I can find out its number of digits further. So we have to run our algorithm, our loop, n times, where n is the number of digits in our maximum element. So times run will be initially 0, and now we will find the number of digits in our maximum element. You can always, there are different ways of finding this. You can always convert this to a string and find it, but this way, according to me, is more faster. What I'm basically doing is I'm dividing it in a loop by 10 and then adding times run to it, incrementing times run. So what basically this does is, let me show an example. For example, if I have a number like 3445, so in the first example, the times run becomes 1 and 345 becomes 3445 becomes 344 because it divides by 10 and it gives us 344.5. But since this is an integer, it is rounded up all the way to 344. And then in the second loop, this becomes 34.4 is 2. Since it is rounded up, it becomes 34. Same way, this becomes 3, and in the end, this becomes 4, and this becomes 0 since we're dividing by 10. So 3445 has 4 digits. Same way, we can find the number of digits of any element in this array. Okay, so now since we have found the number of times we have to run our loop, let's start by creating our bucket array, which will just be a 2D dynamic array with 10 columns. And this will be a vector of one vector of buckets, and I would put 10 columns in it since we have 10 digits, as you can see here, 0 to 9. And now I will also create a int divisor, whose purpose I will explain later in the loop. And now we will start our main loop, which will do all the collection. I will do all the inserting and recollection from the buckets, right? So times run minus minus, this will basically run and decrement times run every single time and run it until it's 0. And now, first what we are going to do is we're going to put our numbers in the respective buckets. So for this, what I'm going to do is I have to grab and here it is input array. So what I have to do is I have to find out the column in which I have to store the bucket number, in which I have to store a specific number based on its nth index. So I will use my little formula here, which I will explain shortly. So what this formula does is it finds the nth index in our number. So for example, if I take 345, and now since my divisor is 1 in my start, so it will be 345, and if I modulo it by 10, mod basically finds the remainder of the number, and so 345 mod 10 is 5, since 5 is the remainder. And we know that we have to put this in the 5th column. As you can evidently see here, it is in the 5th column. So once we know its column, all we do is put it in the respective column, buckets.column. It will index that specific bucket, and pushback basically just appends that number to the bucket, which is our array in this case. So after this is done for every single element, since we are running a range loop in the entire input array, this will work for every single element. And once we are done collecting all the numbers in the buckets, what we do is we clear the input array, because creating a new array for every single time and for every single iteration would really be memory consuming, and hence we don't want that. We want to use what we already have. So I will do input array dot clear, and then once we're done clearing the input array for storage of the new numbers, so we'll start collecting from the bucket. So how it works is left to right and top to bottom. So what I'll start doing is I'll run, I'll run a loop, but this time I will grab a single bucket for the top, so the left to right part, bucket in our array of buckets. Now single bucket is an 1D array itself. It's a one-dimensional array containing the elements which were stored in it in that specific column. So now I will run another range-based for loop, which will grab every single element in that bucket, and what I will do is I will put that element in my input array. Push it back, right? Correct. And now after this is done, push back that ith element. VS Code does a really good job of showing you where you're wrong. And now once you're done with this, what you want to do is clear this bucket, because for the next iteration. So what will happen is you won't have to create a new bucket array for every iteration, and hence reusing memory really helps us save a lot of it and also saves us time from creating new memory and waiting for it to be allocated or our process. So once this is done, our bucket is cleared, and now this our loop is complete. The only thing remaining is our divisor, which we will multiply by 10. And now the logic is that, let me get this up. So first, before it was 1, now it's 10. Since it is multiplied by 10. So 345 divided by 10 would be, let me get this. And now 345 divided by 10 would be 34.5, which will be rounded off to 34 because since this is an integer. 34 modulo 10 is 4, which is in essence is the tens place digit of 345. And hence, as you can observe, we are finding nth digit every single time in the array and just multiplying and finding the nth digit after that. For example, we start from units place, the tens place, and the hundreds place. We go all the way to hundreds place. So for example, if the second gets multiplied by 10, it will become 100, and we'll get something like 3.45, which would be just 3. This modulo by 10, the remainder would be 3. And hence you will have the third digit here. And so this little formula helps us find the nth digit in our little number, which helps us determine the column which we have to store our number in. And that is about it for this code. So if I save it and let me check it once and I run this, I have a sorted array. So if I cross check with my example here, which is this, I'll have the same thing here. 1, 2, 3, 3, 4, 5, 4, 7, 2, 5, 5, 5, 5, 6, 7, and so on and so forth. So if I even if I change my input values here, maybe put 5, 4, 1, 2, 1, 3, 2. And if I run this again, I will get 1, 2, 3, 4, 5. Hence, I will get a sorted array here. And this is Radix sort. It is a very fast algorithm for sorting. As you can see, we have successfully sorted our array using Radix sort. Radix sort is a very simple algorithm. When programmed properly, Radix sort is one of the fastest sorting algorithms for numbers. Whenever you have to sort numbers in the quickest possible way in your critical applications competitive coding, do not hesitate to choose Radix sort over other fast sorting algorithms like merge sort or quick sort. The main disadvantage of Radix sort is when we have long numbers exceeding 9 digits. For example, if I have something like this, in such cases, Radix sort may be slower even if the input list size is less, since it will run the loop n times. And in this case, n would be 13, since this number is 13 digits long, and n is the number of digits the maximum element has. It would run the bucket loop 13 times because Radix sort is mainly dependent on the number of digits the maximum element has. But in any other case, for example, if I have numbers with 7 digits or even 8, Radix sort is the best choice you can have for your sorting needs. And that is about it for this video. I hope you enjoyed it, guys. Please like, comment, share, and subscribe for more content and the YouTube algorithm. And this was Rugved from Coding Geeks, and I will see you next time.